All right, Assalamu alaikum. I don't know if we really need mic, but brother asked me to use it. So thank you everybody for coming. So we'll start since sorry, it's muted. Thank you. So since it's a meetup, we'll start introducing ourselves, right? Okay, I'll pass the mic here. First, myself, I am really a developer. Do some architecture work sometimes, but basically a developer, Java developer. Started with C, C++, then Java, J2EE, and now everybody knows GenAI is in the horizon. So just trying to learn. That's all.
Assalamu alaikum. My name is Esley. I have experience in IT auditing, in compliance. I transitioned into cloud sales, software sales, and now I am a pen tester. So I'm utilizing AI in speeding up the workflow in regards to ethical hacking.
Assalamu alaikum, everyone. My name is Ezra, folks. I'm the brother of Esley, folks. I was also in business-to-business sales. I am now a IT customer service agent, and I'm looking to expand my skills in programming.
Assalamu alaikum everyone. Shahriar Gulreis. I work for a insurance company, and I lead a data engineering team there. Background in data engineering architecture. Recently, I've started working with different AI tools. So bringing all the AI tools and trying to introduce those to my team, trying to find efficiencies. Started using Cursor AI, different tools, whatever we can do to enhance efficiencies in the development environment. So that's what I'm looking forward to here.
Assalamu alaikum, everyone. My name is Sajid Maiman. I'm in the healthcare IT field. Looking to learn from my peers around here how I can. I've taken some boot camps with data science and learning about machine learning, engineering, and all that stuff. So hopefully, I can expand some additional knowledge and help, or talk to other folks too, inshallah.
Assalamu alaikum everyone. My name is Abu Bakr. I am an IT program manager and SME in the area of intelligent automation. So wherein I deal with RPA and the document digitization. So I'm part of the healthcare industry. So looking forward to this session, especially MCP. That's the new year, right? So it's new evaluation in AI. So looking forward to this session. So
Assalamu alaikum. My name is Nadir. I was developer, but currently I'm leading team, not doing much development. My background is mostly with .NET, Java, those technologies. I recently started learning about AI, and also I attended a couple months back Brother Kamrul and Majid's classes. So I just want to continue and stay connected with the group. So that's my main interest. Thank you.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Faizan Khan, and I'm currently pursuing my master's in cybersecurity. So just wanted to know more about AI. So alhamdulillah, currently in my second year of my master's, about to finish my master's in 1 year. Sure.
Assalamu alaikum, Mohsin Ansari. I'm in project management field, working for the insurance company. And our company started using the AI tools and all that. So I'm here just to get what others are doing and what can I learn and all that. Thank you.
Yeah, Assalamu alaikum, brothers. So my name is Majid Khan. So not to be confused with brother Sayyid Majid, who is absent today. So he's the actually expert here, but I'm not. I'm from the infrastructure platform engineering side, actually working for an insurance company, and I'm here just to learn and gain knowledge about the AI, which is seems to be more future. So from all you guys, and that's why I'm here to get involved. Thank you.
Assalamu alaikum. My name is Mansoor Sheikh. I work for an investment bank leading a risk analytics team. Pretty much here, I'm learning AI by myself a little bit. Just wanted to gain more experience and see what's there.
Assalamu alaikum. My name is Zaid Sheikh. I am currently a master's student at NJIT doing material science. Programming wise, I've done Python in the past, mainly for data analysis. AI wise, not so much. I'm here out of personal interest.
Assalamu alaikum. Munir Mohammed. I'm a IEEE member as well, and I am an AI ethicist. So basically looking mainly into the ethical aspects of AI, and I work as a product development, and I've been with IEEE and also working on AI for quite some time now.
Assalamu alaikum. My name is Hafiz. I'm an IT program manager. So I want to explore the possibilities of how to implement AI into IT infrastructure services. So I've started exploring. So that's the reason I'm here.
Assalamu alaikum, brothers. Name's Arif Mustafa. I'm just like you. Started as a Java developer. I'm a .NET developer, lead architect. Mostly been working with financial institutions here for a long time. Like everyone started using AI in the firms. They've started introducing AI. So does my firm too. So I also aspire to become an AI ML engineer in the long run. So that's part of the reason I'm here.
Assalamu alaikum. My name is Imdad. I am a Java engineer working on microservices, and I'm trying to learn the Gen AI in the long run, get to know how it is impacting the business in current era.
Assalamu alaikum everybody. My name is Diwan. I am an application developer working for a company called Blackline, and we are in financial closed domain. Like after all the accounts are done, like accounts, journal posting, reconciliations, quarter closing, month end closing. So how to speed up and automate it? That's what we do. And my day-to-day is product development with Blackline. Touch with AI is using AI on a everyday basis to get my job done efficiently and more faster than how it was earlier. So today I'll see if I can contribute to the MCP session today. It's not like we have built too many MCP servers as such, but it's more of what I have learned so far and want to share with the community on like what we have learned so far. So the reason why we want to do this, even if we have not done any production level MCP servers, is that the space is evolving super fast. It's super fast that by the time we are out of this room, we'll have 2 more MCP servers out there live. So it's so fast that it's impossible for each one of us to be up to date on what's happening by themselves. So that's the whole idea of being here today. See how we can all get better together. Thanks.
Assalamu alaikum. My name is Adnan, aka Syed Rizvi. So predominantly I work on the Microsoft Dynamics platform, and I have been sort of in and out of AI on the Microsoft platform. My day-to-day work is around Microsoft products and the impact of AI on it. So I wanted to see what's outside Microsoft, since inside things are a little bit on the, and they are enclosed, not that much options of doing anything beyond Microsoft. So I want to see what's out there and hopefully help myself learn some more.
Assalamu alaikum, everybody. I'm Naveed Ahmed. I'm working as a Java backend developer for a telecom client, working with chatbots currently. Looking forward to learn more about it, Gen AI and how to use that in backend development.
Assalamu alaikum. I'm Mushi Buyan. As far as using AI, I have been using AI before even ChatGPT started in 2022. But recently, I started working for Navy Federal Credit Union, and since I started, it was 2 weeks, 3 weeks. Just try run, just see how it's going to work out, and then since then I fell in love with the organization somewhat. I am right now leading their enterprise. They call it enterprise platform architect. Just next generation of banking side, what Federal is doing with the technology, and AI is one of the key things. I think later I'll share with you how we are using internally. But all of you know, when it comes to financial institute and government, they don't touch AI that quick. But we are going live this quarter with one product, and there is 10 more products in the pipeline. I'll share with you later.
Assalamu alaikum everyone. Tawheed Chaudhry. I work with Mark, and that's my day job. After that, I have many other ventures, working many different projects. One of them is AI, and other of them is working in the diaspora area of Bangladeshi community. So that's why here I'm also connecting with people, talk about AI, and provide some insights and get some insights in regards to enterprise agile coaching.
Assalamu alaikum everyone. My name is Muhammad Tahir. I'm working as a tech lead in the field of business intelligence and data warehousing. Mostly I'm working for MicroStrategy, Power BI analytics side, and wanted to learn more on the AI and explore automation and different CI/CD which we can use AI in this field. So I'm here.
Assalamu alaikum everyone. My name is Basharat Mohammed, and I work with Mondelez International as a data analytics lead. I've been in data analytics since 2008, playing various roles, and I'm currently working as a product lead in Mondelez, and I would like to learn more about AI and how to implement AI solutions.
Assalamu alaikum. My name is Ashraf Kareem. I work at PSNG, working in the cloud infrastructure with AWS. We're looking at data AI and a lot of security concerns, obviously. So we're working towards getting AI approved from our security team. But I'd like to definitely know a lot about that, and so joining here.
Assalamu alaikum. I'm Ammar. I have done my deep learning masters from NYU. I'm working at Barclays, work in front office. We have started exploring Gen AI with AWS Bedrock and Flu AI and other tools. So yeah. So I completed my master's.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Khaisar Ayaz, and I've been working with Oracle DBA on the database side as an architecture for almost more than 20 years. And AI is a black box for me. So I just want to peep inside and see how it is.
Assalamu alaikum. My name is Sana. I'm a system engineer. I'm here to learn about Gen AI and how I can implement it in my everyday tasks. Thank you.
Online, yeah, I don't know if they do how the mic will work, right? We can try. There's not many, but okay, yeah, we'll skip it. Okay. So we'll go on with our agenda. First, we had this agentic development, right? So I'm not an expert myself, but I thought this will be a topic which I can do a little bit of presentation, agentic development. So as we all know, this is the term floating around now, right? Agentic development. Now what it is, and I'll basically touch on the concepts, how it came along and how we can utilize it, right? So first, we have to know like the LLM, the different other presentation. Okay. So we have to start with like why we are in this journey, right? The agentic development. Now LLM, we all know like the LLMs are in business now, right? Different companies have their own LLMs, but generally, what is LLM and what it is capable of, right? So it's basically a neural network thinking like human, right? That we all agree now, right? It can think like human. It can pass the bar exam with flying colors, right? So that cannot be done just with a dumb machine, right? It can think like a human. And it can also work faster than human, right? Because we get tired, machines don't get tired. It has a large swath of, like it can access a large swath of information, right? Although as humans, we only utilize, I think it's like 30% or 40% of our neurons. But so human can like store much more than what we currently do, but there are other limitations, right? Which machines don't have those limitations, and it's advancing every day, right? So it can access a large amount of information. Now if it can do so much, then where is the use of human, right? That I guess a lot of us are afraid what is coming, like us as developers, us as even scientists, even like doctors. Every field will be impacted, will be impacted by these LLMs. So we can talk only what we see today, right? I mean, I don't think anybody has full picture of what is coming within 5 years, 10 years, right? Please feel free to question. Like, I'm not an expert, just I'm just telling what we are seeing now. So please inject and put your opinion too. So what it is not capable of currently is like the knowledge base it has a cutoff date, right? Like ChatGPT or their models has a cutoff date. other models as a cut-off date. So it doesn't know the information beyond that date, right? So, and the second restriction we all developers are trying to fill the gap, right? That it cannot, obviously for the same reasons, it cannot access any proprietary information, right? When it was trained, obviously all our company information, those kind of PDFs, those are not available to the LLM, right? And those will not be in foreseeable future, right? For the right reasons. So, and then, okay, then the question may come like, okay, then we will train the LLM with this new data, right? If we have our own LLM in-house, which may not be always possible for different reasons, but we can train it on new data, right? But training on new data, that's also not very cheap. It's a costly thing. I'm just describing this like limitations. The reason is that's where our involvement comes in, right? That's where we are trying to fill the gap. And then what I saw, this is one of my observation, and I saw in one of the presentation also, that when these LLMs, of course, if you're familiar with the programming, it can call a tool, right? It can call a function outside the LLM, process, right? You submit a question, and then it goes through its network. But you can give it a function call, like a software function, it can call. But when that function is called, that control is returned to the user. So it's no more, the LLM is no more thinking it in its own term. It's returned to the user. Now at that point, if you want it to go any further, you have to call another function or return to the control to the LLM. So that's where human involvement comes in, right? I mean, it's not like a human being. You give it a complex task, it knows where to get the data, gets the data, and then it goes to the second step, right? So before going to the second step, that's a human involvement. So that's where we come in as developers, as engineers. And then performing a complex task is still, what I see, still not in the generally available feature of LLMs. So if we'll see some example, but if there are, say for example, you ask it to write an essay, right? Now, there could be, it can write an essay and it will give you the output, but it can be made much better if you give further inputs, right? Because you can see some mistakes, you can feed that input and then ask it to do it again 2-3 times. Then it will do a much better job, right? It will output much better essay. Yeah, actually, prompt engineering, I mean, when the term first came in, I was a little bit wary of that term myself, that, okay, prompt engineering is you give it a right prompt. Now, as LLMs get smarter, I mean, it will understand much better also. So then what happens to the prompt engineering? Like then the importance of prompt engineering becomes less. Okay. Yeah, what I'm trying to get to is like prompt engineering really like it spans much more than what people initially thought, that you just write it in a nice way, you tell it some preamble, that okay, you are this kind of agent, do this, and then your question. It's not only that, it's much more, right? Because these LLMs are nothing but neural network. Now the neural network, I mean, it has its own working, right? The way it works. So if you prompt it the right way, the way it works, then you will get better result. So, yeah.
Trained, with more data, right? As we go, LLMs are getting smarter in a way where they can actually give you the right prompts. They can help you build prompts, right? You have to give, you can start with basic prompting and then ask the LLM to actually create a prompt for you, which you can then use and feed it back into the LLM. And then you can keep enhancing your prompts using LLM's knowledge and capabilities. And then you come up with a really complex prompt, which you as a individual may not have been able to do it. So we are getting to that point where LLMs can potentially generate prompts, and you probably, I mean, right now I know, it's a new field and new, people are still learning, catching up, but eventually LLMs will get to a point where they can actually generate these prompts much better than a human can.
That's where it's heading, really. Like, what I was trying to say is this prompt engineering, it's a much bigger field, and this agentic workflow kind of like goes under that like area. Really, I mean, with agentic workflow, these agents are trying to employ the LLM to come up with better answers, right? That's what it is. That's how I see it. So, like I was saying, what we were seeing earlier, that what are the limitations, and that's where we come in, that how we can fill in the gap, right? So, RAG, you probably, a lot of you are familiar with, right? Retrieval Augmented Generation. That is used to fill in the gap that the LLM itself doesn't have the proprietary and current information, right? So the RAG mechanism, it can access the external information and feed it to LLM as a context. That's what RAG is. And then there is MCP, which is basically assisting RAG with a mechanism that you can access information from a varied resource, right? Varied type of resource. You can access the information in a uniform way to feed into LLM. But again, all of this, like whether you go through RAG or MCP, basically you are getting the information and passing it to the LLM as context. Not so much, not at all actually, to train the network. You are not changing its brain. The brain itself is what it was trained on. If it is the information like since 2021, that's what it knows, and it will know. It will never know beyond that unless you feed it as a context. So, and then agentic development, like we said, that till now, whatever LLMs are there, very complex tasks, it cannot do on its own. Like there are some involvement necessary. So agentic development kind of like tries to fill in that gap. So these are So these are some, actually this term of AI agent is not new, right? Although in generative AI context, the meaning really has changed. But what we used to call agents, these are the virtual assistants, the customer support bots, all of these were called AI agents. That's what the current like definition is, and really the definition of AI agent, it's varied. Like a lot of definitions are there. Some you might agree, some you may not agree. We'll just try to come up with some general general answer. So here's something I captured from, I think it was Hugging Face. So their definition is what we call agent. Most of them are not agent really. If it doesn't have some intelligence in there, they say it's a workflow. It's not an agent. So there are some examples here. I think the first one is called like a prompt chaining. So you pass a question to one LLM, then you get the response. There is some mechanism like logic in the gate, and then you pass it to another LLM. That's called like a prompt chaining. Then the second one, it's called a LLM router. So you pass your initial question to one LLM, then the output is routed to another set of LLMs depending on some logic, right? So that's the router, and then the third one, they call it like an orchestrator workflow. These are all still, they call it they call workflow. So you pass your question to an orchestrator, and then that orchestrator pass it to two different LLMs depending on the logic. And now the router and the orchestrator, I think the difference is router, you route it to one, and the orchestrator, you just divide the work between two LLM depending on the work. And then the output from the two LLM comes through a synthesizer, which then like synthesize both the outputs and give it to the user. So coming back to agentic AI development, so few things can be said about agentic development. So it's specific to generative AI. It's not so much you can relate it to like the artificial intelligence we had before generative AI. So it is specific to generative AI because the agent itself has to have some mechanism so that it shows that it is thinking itself. It's not just employing the LLM. It's a thinking mechanism it has by itself. And so it has to employ the LLMs as the thinking brain, and it has to be, I mean, again, it relates to the first bullet, that it has to be some type of autonomy has to be there. It cannot be just the flow what we were seeing in earlier slide. So that's called autonomy, and it has to be there in order for it to be called an agent. So this is a pattern they are following. They are following today for agentic development. I mean, there might be other patterns there, and more might be coming. But this is a pattern which they call REACT. Basically, it goes to the process of thought, action, and observation. So we have to think of it like a human does, right? Say, for example, you wanna bake a cake, right? So the thought is you have to bake a cake and you need the ingredients, right? You need flour, you need sugar, you need milk, and then the action is what? You have to go to the refrigerator, bring your items, and then bake it, right? That's the action. And then the observation is whether the cake is at the right temperature, baked okay or not. If it is not, then what do? You go back to this loop, right? You have to think what you can do. Whether you can put it in the same temperature, probably not, right? Then it will burn. You have to put it to a lower temperature, maybe for a lower amount of time, and put it in the oven, and then observe again that whether it's ready or not to be consumed, right? Yes. Oh, they are not able to hear, or is it faint? It was unmuted. Really? It was unmuted. Can you guys hear now? Zoom folks? Okay, all right, thank you. Oh, wow, we missed it. Actually, we are gonna record it, so. Maybe my AI bot could. I could not, as a human being, right? Actually, there are these examples, so that will probably do it. Yeah. It didn't ask. Right, video. I turned it off. Yeah. Okay. I guess I'm taking too much time now. Okay. Oh yeah, but okay. All right. So next slide. So now it's time for a demo. Okay, so on Zoom. Why is that? This one. No, but it's not coming here. Python. Yeah, now. Okay, okay. Now we have to show. Yeah, I think it's coming now. Okay. All right, technical difficulty, right? Maybe it will be done by AI soon, right? Very soon. Okay. Okay, we'll do away with recording for now. This is an example of like agentic development, right? Now, what it does is basically it asks the question of like what's the mass of a planet times some 2 times or 5 times, whatever, right? So it from outside we are providing 2 functions, right? One is like which planet like weighs how much, and then another function is just to multiply it by whatever number of times user asks. So what does our agent do? Basically, let me just go through the code. This is done through the Grok models, and let me first just install the Grok, and first is just tries one query from the model that explain the importance of first language models, and it gets the output, right? Now here is the agent. So the agent, this is the agent class, and it has 3 methods in there. One is for initialization, one is for calling the agent itself, and then the execute is basically it calls the LLM from inside the call function. It like executes the LLM call. So here is the system prompt. Now, I mean, by agents, we may think that agent itself has some kind of logic we have to program, and for all of these available, like in the market, available framework, those things are hidden, right? I mean, you might think like you have to use one of these framework to have that logic, right? But it's basically nothing but instructing the LLM to what to do. That's all an agent is, and you are not doing any of like your what I should say, like thinking logic in the agent. As you can see here, it's done mostly through the system prompt. So like the in the previous slide, right? Our flow was that pattern was what? Think, action, and then thought, action, and observation, right? So what we are doing here is, as you can see in the system prompt, it just instructing the LLM, you run in a loop. This is done by one of the bloggers, this prompt. And like we were saying before, right? Prompt engineering is really the most important thing you are doing for LLM programming. So whoever came up with this prompt, he set the stage for this like agent flow. And that prompt, as you can see, it says you run in a loop of thought, action, and then introduced one string as pause, and then observation, right? You are in plain English, you are just telling the agent what to do. You run in a loop of thought, action, pause, and observation. At the end of the loop, you output an answer. Use thought to describe your thoughts about the question you have been asked. Use action to run one of the actions available to you. Then return pause. All of these are simple English commands to the LLM. And then the LLM will act accordingly. Like you are not doing any Java programming or any other kind of programming. Just in a plain English, you are programming the LLM. Is that clear? If you have any question, clarification, just let me know. This is the single most important thing, in my opinion, to understand about agentic development. You are basically in natural language instructing the LLM what to do. And that's all agentic development is, agentic programming is. Now, how they came up with this paradigm or the pattern, like thought, action, observation, they have to know that how the LLM really works and how LLM is mimicking human brain through that workflow, through that pattern. So that's why they came up with this pattern, thought, action, and observation. And then it's describing that the available actions are calculate. It's giving an example that calculate works this way. For example, 4 times 7 by 3. It runs a calculation and returns the number. Uses Python to be sure. Use floating point syntax if necessary. All of these are instructions, right? Then it gives an example of a session, right? That if the question is what is the mass of the earth times 2, what would be the thought? The thought would be, I need to find the mass of the earth, right? That's the thought. If somebody asks a question, okay, that's the thought LLM should have. And then what should be the action? The action would be you call that function with parameter of earth. That's an instruction to the LLM. And then it says you will pause. And when it says pause, it will return the control to the user. And returning the control to the user at this point is necessary because, see, it will call a Python function, right? Now, if you allow the LLM, see, that's another restriction at this point in time, that you cannot ask the LLM to run something in your environment, right? At least we are not confident enough yet, because it can run some malicious code. It can destroy your environment. So when the control is returned to the user, there has to be some check that, okay, this is okay to run, and whatever environment, the parameters it has to run, somebody has to make sure that that is followed. So it says pause, and then you will be called again with the observation that the planet of the mass of the planet is, for example, that number. And then the thought would be, what would be the next thought? Next thought would be that it has to be multiplied by 2, right? That's what user is asking. That's the next thought. It's in the, if you think about the loop, That's the next loop it should go through. So then what would be the next action? Next action would be the call the other function just to multiply by 2. I mean, this is a simple example just to understand, right? In reality, the LLM itself could do all of this. But in practical cases, you will have actions in your environment which is not available to the LLM, right? So it has to call a function which you provide to get that answer. So then it will be called again, and this time it should realize that it has the answer, and then it will return the input to the output to the user, right? That okay, this is my answer. So we are providing those two functions in our agent, the Python functions. Now, next line of code is so like a real life agent, right? So you call that class and you pass two parameters to that. First one is the client. Client is the model which what you want to use. In our case, that Grok model. And then the other parameter is the system prompt, which we just went through, right? Giving all those instructions. That's the system prompt. So you call that class with these two parameters. You get an object, and this YouTuber, he is calling it as Neil Tyson, right? Neil deGrasse Tyson. He's the expert in all of this. Physics and stuff, right? So he calls him Neil Tyson. So then next line of code is it's passing the prompt to Neil Tyson that what is the mass of the Earth times 5, and it is printing the result, which is I need to find the mass of Earth. So if we go back and go through the code, so it called the init, right? When we create the object, it called the init, and init means it passes the system prompt, right? It passes the system prompt in the object, and then it calls. Here, the next one is the call, and if you look at this function, as you can see, it is appending the message with a role of user, and the content is the message we are passing, right? Content is the message we are passing, and then it's executing when it says self.execute, it actually calls the model, right? It calls the model, and then it gets the result. So then, as you can see in the next line, with the role of assistant, so now these two roles, the modern day LLMs, all of these LLMs have different roles, right? System prompt is the initial instruction you give. User prompt is whatever the user is asking, that question you pass. And then the role of assistant, that's the result the LLM gives back. So you append that to your existing messages because you want to go in a loop. That's why you are like appending. So then it returns the result. Now, so result is what the LLM is returning, right? When you say self.execute, the return is the result. And what we see from our example, the output is, what is the output here? From the model. I need to find the mass. See, that's what, just giving that instruction in the system prompt it knows what to do. See, in the agent, we did not program anything else, any logic in there other than giving instruction to the LLM. So LLM is going to the system prompt and is exactly doing what I asked it to do. That it's returning just a thought, that at this point, it only thing is like I should come up with a thought, and the thought is I need to find the mass of Earth. And then it just shows what current state of the message is. As you can see, I'll pass through this a little bit quicker. If you are interested, we can really have some sessions on agentic development with current frameworks and all these basics. I think it will be helpful. But let me go through a little bit faster. So as you can see here, the messages currently residing in that object, Neil Tyson, right? The messages are with the role of system. It has all those instructions we already provided. Now it appended with the role of user, whatever we asked, right? What is the mass of the Earth times 5, role of user. And then with the role of assistant, it like appended the result from the LLM, which is the thought, I need to find the mass of Earth. So that's all residing in that object currently. So now what would be our next step? So now we call the agent again, right? And all of those instructions are already in the object. So if we call the agent again, what would be the result? The result would be action, that at this point it has to take an action, right? And that action is get planet mass and with a parameter of Earth. And it would also, as we instructed, it would also like return the string of pause, P-A-U-S-E, pause, right? So it's doing exactly what we asked the agent to do. And then we call the function, right? Now, as we were saying earlier, that these methods or these actions are internal to our environment, right? So we have to call. LLM cannot call directly this get planet mass. That's a Python function residing in our environment, in our code here. LLM doesn't have access to it. So we call that function, right? Get planet mass. We call that function, and now the output is the observation, right? We already went through thought, action, and then now it should be the observation. So the observation is that it would call the get planet mass Earth, and the observation is the result. And actually, we should pass the observation, right? So we create the prompt with the observation, and then we call the agent with that observation. As you can see here, the agent is called with that observation. And so if we call it with that observation, what should be the next thing in the loop? We already went through thought, action, and observation. Thought again, right? So it's going through that loop. So now the thought is, it understands what you asked before, right? So now the thought is, I have to multiply it by 5. So that's the thought. And then it also, our agent itself appends the message, appends the output to the message. That now, if you look at the last line, it's attaching the message to the role of assistant. right? So it's in that message. And now if we call again the agent, the result would be that this is the output, right? This is the action. This is the action that we have to do. If we call the calculate function, and the whatever it comes up with times 5, that's our observation. Now, at this point, when we pass this observation, the agent itself will know that this is the final answer, right? We are not providing any logic or anything. The agent, not the agent, I'm sorry, the LLM. The LLM knows that this is the answer they're asking for, and then it will come out of that loop automatically. I'm not saying anything that, okay, come out at that loop at this point, do it 2 times, and then come out. Then it would be like just conventional programming, right? But I'm not saying anything. I'm just saying I gave the instruction in natural language that go through this loop, find me this answer. When it says that, okay, I already multiplied it, I got the mass, and I already multiplied it by 2, that means I have the answer. So then it will come out of the loop, and it will give the answer to the user. So now what, I guess I'm taking too much time maybe, but so what we have done so far is call the steps in the agent kind of manually, right? Call the function once and then pass it as a thought. So what we have to do is in that agent, we now like kind of automate it, right? That how we automate it, the LLM itself outputs when we pass it a prompt, right? Itself outputs and it says what action it needs to take and the parameters. So we have to loop through that message, and whenever we see an action, we just call that function with the parameter. And when you hear about frameworks, right, whether like Hugging Face framework or other framework, what those frameworks are doing is nothing but just this piece of code. That they are passing the system prompt that, okay, do this, and then if user is providing some external functions as tools, call them at the right time, feed it to the LLM again, and then come back with the result, whatever LLM is passing back. So that's all that this piece of code is doing. Like it has a loop, and as you can see, there is a max iteration here. And this is what user can control, right? In agentic workflow, you can, this is a simple example, right? I mean, I don't think it will ever go wrong in this type of question. But if you have a complex question, it's going through some ethical stuff, and is going again and again, it may happen. So in that case, user can supply a max iteration that, okay, you go through this loop 10 times, 15 times. If you can find an answer, whatever you have, give it back. So that's a user-controlled parameter in the agent. In this case, it's hard-coded to 10, as you can see in the top line, but it can be from a user-supplied parameter. So, so that's basically it, from agentic development. I have a few more slides, but I think Brother Dewan is getting impatient. So let's see. So this is something I got from, you probably heard about Andrew Yang. He's very big in this agentic development and then like generative AI generally. This is the layers architecture he showed where we talked about product development, right? So this is the space. I mean, the foundation models, we cannot do anything, I guess, in this audience. Maybe Esli can do something at that level, like manipulating the foundation models. But most of us can't. We have to focus on the top layer, which is the application layer, right? With all this agentic development and all of that. So then here, for the product development, I think there is a new paradigm coming up because of all this agentic development. As you can see, the example I showed you, we just supplied a system prompt, right? Do this, this, this. It did everything else on its own. So how much involvement does a developer have? Whatever took like 2 months, now it will take not even a week. So that learning process would be very quick, right? As you can see from top, it's like a 3-month cycle. Now the LLM based development would be probably 1 week. So what he was saying, now the bottleneck is before you deploy in production, you have to test it, right? Test it and see if it is really production ready. It doesn't have any ethical concern. It doesn't have any harmful effect. So that is taking time after this development. So that's where industry is trying to find like how that process, like the DevOps and all of that, how that process can be made faster. Okay, this is I think what I just described. This will probably repeat also. Not ChatGPT itself, but this is how, say, other frameworks. You know, this Hugging Face and other companies or the open source frameworks, they have those agents, right? And I saw Hugging Face has another agent called Code Agent. So Code Agent is nothing but telling the LLM to run some Python code. Now, as we said earlier, running some Python code on itself has its own problem, right? It has to be told what are the restrictions, what packages it cannot download, it should not download, things like that. But once you provide that, if you provide a piece of code, they were showing that code agents work much faster. So everybody is coming up with those agents which can work better with the models. Now, some models may have some capability which others don't. That's where I guess all the engineers and the LLM experts have to jump in that, okay, this is what works, this is what doesn't work, these are the limitations and things like that. So I'll just end with this fictitious line of events, what came to my mind. You can see whether it will make sense. So in a few, maybe not in a few years, maybe in a year or so, or a couple of years, so you are walking out the door with your smartphone, it beeps, and it says, today you have a client meeting at 10 a.m., right? You should already see that this is happening, right? There are products out there which is automating all your calendars and everything. So it will beep and it will tell you that 10 a.m. you have a meeting and your agent is telling you that your presentation is ready. But I have to convey you a sad message that somebody called from back home and left a message for you. So back home, I mean, I use Bangladesh as my own country. So I'm in Bangladesh. What is it? So the agent will tell you your mother had a severe stroke and she's in hospital. So it knows already from its network that that message was conveyed to yourself through that agent that somebody is sick back home. So then says, oh my God, I need to go buy a ticket. So the agent will ask you, do you need to reschedule your meeting because you have a meeting at 10 a.m.? I says, yes, please. Agent will say, I'm on it. It will reschedule the meeting and everything. But then it will say, it will try to buy a ticket for the person, right? And it will go through all its personal stuff. It will see that it will talk to another agent which manages his passport, and the passport agent might tell this other agent that it needs renewal, it's expired. So it will say it needs an urgent renewal and it needs to send the payment. It will ask whether I should send the payment, and if you say okay, it will send the payment. Well, it didn't say, maybe that's a good question. Maybe it regularly should monitor, right? But it didn't see the need until it needed to buy a ticket, right? So I think this is happening probably very soon in a few years, a couple of years. Proactive, yeah. That would be dangerous, though. I mean, if it does everything proactive, then yeah. All right, I'll end here. And yes, please. Yeah. Right. Yeah. So. Yeah, you have to set that up, and then for the agent, actually, that's one of the requirement that every agent works within its restricted perimeter, and the guardrails are provided by the user. That okay. I mean, if you don't want your agent to do the payment, you should be able to set it up. That okay, I don't want you to do the payment by yourself. Those guardrails will be provided by the user. Yeah, I think those are the restrictions for the agentic workflow. I didn't go through that, but guardrails and giving the restrictions, like that number of iterations, right? So it's the user who is giving that instructions that don't go beyond 10 iterations. Give me the result back once you hit the 10th iteration. So those are the guardrails the agent should have. That's an evolving field, actually. That's where actually companies are not able to trust yet that what extent I should let these agents go. That's what my understanding is. That's an evolving thing today. Now how far it will go, like how far it will be allowed, that's yet to be seen. I mean, you know what is being said, right? That the agents itself can replicate itself. So those are the things, I guess, nobody knows at this point, or the extent of it, nobody knows. All right. Thank you for listening, and next speaker is Brother Diwan. We'll go over MCP service.
Thank you. Do you guys mind if I sit and do it, or do you want me to stand? Thank you.
There's coffee in the back and samosa is here. Coffee you have to make.
For online folks, we are taking a break. 5 minutes.
Hello, hello. Yeah, brothers in Zoom will. You can hear us, brothers? Brothers, can you hear? Okay. You are missing the samosas. Oh, the people are saying it's very tasty. Potato samosas. Oh, no, I think you should be able to share. Let me stop share. Okay. Yeah. Let me mute here and. Okay, brothers. So please come back and we'll start now.
I'll see this one. Easy for me. Okay, just we'll try to run quickly from here. So I'll see if I can how much of depth I can go in relation to MCP servers and how it is getting applicable in our is my voice clear? Okay, fine. Yeah. All right. Right. So I don't have any presentations or PPT, just like how Brother Kamrul did here. So what I'm going to do is just use one of my LinkedIn posts which I wrote last week to show here. So the screen is going to be a lot of theory, but you can follow along with me when as I speak with it. So you don't have to really go through reading the whole theory there. I'll anyway share this link after the session as well. So it's anyway public. So shouldn't be a big deal, right? Reason. So why did MCP come across, right? And why is it being spoken about a lot these days? That's a small background on, right? Like how Brother Kamrul was talking about RAG, retrieval augmented generation, right? So LLMs, what's the problem? Even though LLMs are trained upon a lot of general data, right? Should I? Okay, I should. I think maybe I should join with computer audio. Hold on. Okay. Online folks, are you able to hear now? Brother Julfi, Buhari, anyone?
You can hear now.
Yeah, you leave the audio. You leave the audio, I will stay in the audio, okay? Okay, so very quickly, right? So before I go into the whole session, what are we going to see is why did MCPs come into picture, right? What's the problem they are trying to solve? and what is the architecture of the MCPs, and what's the communication modes they are using, the protocols underlying the MCP tools, right? And we will also see a little bit of hello world level demos on how to use this. We'll get around a little bit of security and all those areas. One thing to keep in mind is this area is changing very, very rapidly, like as we speak. I'm not just talking about the new MCP servers itself, the specifications and the aspects around how to build an MCP server, right, and how these things operate, and what kind of guardrail should be in place. All those things are being written in a spec, right? And this spec is changing as we speak. So whatever you see here might not be relevant or might not stay the same after a month or two. Things will change. So best is to keep following this very closely, right? So let's quickly see what is the problem that they are trying to solve, right? So cutoff dates for LLMs, right? So if you ask, if I don't know like how many people have been using ChatGPT from how long, but if you would use GPT like 7 months to at least a year ago, if you ask like how is the weather today, GPT won't know. Why? Cutoff date, right? They have a predetermined set of data these models get trained upon, and beyond that scope of data, they don't know anything. They are as dumb as that their data. That's it, right? They don't know anything about it. So if you want to use the LLM to do something with your organization's data, they couldn't do anything. That's where RAG came in, Retrieval Augmented Generation. What that did was, okay, I will allow you to take all the organizational data, maybe some PDFs or some templates that you have within your organization that you don't want to share to public, right? I can create embeddings out of that document, and I can store it into a vector space, and I can give that embeddings to the LLMs, and the LLMs can understand, and LLMs suddenly will have context about your own data. Now, that was happily working for some time, right? Where it failed was the context window. I won't say it failed. It's like beyond a certain limit, RAG is not able to solve problems. It can only solve a problem as much as the context window of the LLM allows it to. So you could take 2000 PDFs and you could stuff it into a vector space, and you could give that as a context to your LLM, right? Your LLM, when I say LLM, what am I meaning? So for example, you are using this GPT-4 model from your local, right? So you have it in your Azure instance or somewhere, and you are invoking the APIs from your local, right? And as soon as you give all this context into the picture, the LLM itself has to keep a memory of the current session of what is going on. That's called context, right? Now as much of data as you put inside that context, there is only so much of space that you can put over there, right? Either beyond that, it will start missing out on the data which you initially gave, right? Or the space itself will be limited. Maybe you have a lot of data that you want to stuff into its context. It doesn't have that space, right? So that's what RAG was trying to solve, but only to a certain limit. even now, RAG is relevant to a certain limit again, right? Certain number of documents can still be, you can turn it into embeddings, you can put it into a vector space, you can add it as part of an external knowledge that you are trying to serve, right? So when, so Brother Kamrul spoke about the function and tool calling, right? Function calling itself is the ability of the LLM to ask for external data to get some work done outside its ability, right? If you see, when RAG was not solving enough problems, companies like OpenAI, Claude, everybody started writing implementations of their own using function calling to get information on real time outside the model's limits. That's when Anthropic, right? Anthropic is the company who is behind Claude. Claude is also one such model. I don't know. I'm like many are very familiar with GPT, but not so many are familiar with Claude. But I would say developers, everybody should be familiar with Claude. This is from my own personal experience, right? I have tested with both Claude and OpenAI, same set of problems, same set of prompts. Claude would give much better outputs compared to GPT. Okay, and this is improving again every day. And even today, Claude is the benchmark that everybody is trying to beat. Whoever is coming new into the space, they are trying, in terms of code, right? How you write code, how the LLMs can understand code, and how can they spit out code back to us. Just in that terms, right? Claude is the benchmark that all the other LLMs are good. I mean, trying to beat. GPT is doing fantastic in general purpose, right? Again, when you are trying to hire a developer, you want to hire a developer, not a handyman who can develop, right? So you want that specialized knowledge. That's where Claude comes in. But that's out of the scope of this talk, right? So what Anthropic did was, okay, if you, in that case, let's come up with a standardized way of talking to LLMs, and that's what they called it as Model Context Protocol. You are setting a framework or a specifications on how you are going to provide additional external context to your models. This model can be anything. This model can be a Ollama model running on your local machine. It can be a Qwen, can be an external closed models like GPT, Claude, whatever it is, right? The specifications is standard, right? So if we think of this a little bit behind on what did REST do, REST, right? RESTful APIs, right? And they brought in a set of standards that can be used across the web applications for them to talk to each other, right? Even before REST, there was SOAP, right? SOAP was solving a problem, but as and when the types of clients who are connecting to these web endpoints varied, a lot of mobiles came, endpoints had to be lightweight, payloads had to be lightweight, sorry, right? So REST came in and they had a lot of specifications put in. So this is very analogous to that evolution, right? So what Anthropic did is, okay, we'll create this MCP, right? If you see how they have laid out these standards is that they are saying every MCP, this whole architecture is a client server architecture, right? Like you see in the slide, right? The server client, and a host. So when I say server, don't immediately think of it as like a big black box server sitting somewhere, or it's not even a node or any Docker, any node which is running somewhere, or not a Kubernetes node which is running somewhere, right? It's not that. Server is, these nomenclatures are more semantics on how you are drawing the lines between the responsibilities of these things are working or doing their jobs, basically. So servers, if you see, are their job is to expose three things as of today. So for whatever I say is as of today, right? Three things: tools, resources, prompts. Tools, of course they have to, that's their sole job. Sometimes resources as well. Prompts, optional. Okay, we will go into a little bit deeper in a minute on what these things do. When I say client and host, there is a very bleak difference between what's a client and a host, right? For example, if you're writing a web application and you want to connect to probably Jira API, right? What would you do? You would write a HTTP client to that 2 lines of code that you write there to connect to your Jira API. That's the client. But your web application where that code is sitting, that's the host, right? Similarly, I don't know how many are using VS Code. Like, anybody uses VS Code and Cursor, Windsurf, all this stuff? Yes. So when you're using these, again, almost all of them are VS Code basically, right? Same VS Code folks. Now, the GPT Copilot that you use along with your VS Code, right? Your VS Code is the host. That's having, so VS Code along with the GPT client, the Copilot client that you are using along with it are the host, right? That host is where you are selecting. So you're doing this, right? So you are taking, this is VS Code, right? And you are opening, how to make this disappear? Okay. So here, when you're doing an open chat, right? So, oh, sorry. All right. So this whole thing, right, is the host. But as soon as you start saying something to you choose a model and you start communicating with it, that's where your client is instantiated. Okay. Now, so client and host, don't have to get too much confused on that. Just think them as same at this point, right? It's not so different. Let's then get into what MCP servers are, the components, main components, right? So I told there is 3 things they did. They have, right, tools, resources, and prompts. Okay, I'm not even going to go inside prompts. We'll just have tools and resources here for sake of this talk today, right? So tools are nothing but the so think of it like a hammer or a screwdriver that you use, right? And these are the tools that you are providing your LLMs who are going to communicate to your MCP servers and ask for the tools. Okay, so saying that, okay, I am a, so when and again, when I'm saying LLMs itself, right? It's I'm not saying that it's a Claude model or an Olama model, right? Whoever is using those models, right? They are the ones who will be using these things. So how do they use these things? And main push on why these things are getting so talked about these days is because of agents, Okay, agents are given. Every agent can use its own LLM. I hope most of you here know about this already. Every agent can use its own LLM, and an agent can be given access to one or more multiple MCP servers, right? And that's how an agent is being given tools through those MCP servers to do its job, right? So that's how an LLM gets access to a MCP server, basically, right? So that's how you need to think of these things as, right? Now, again, stop me right there when you have questions. Let's keep this a little bit interactive. We'll try to wrap in another 20 to 25 minutes, basically, right? Okay, so yes. Yes. Right. So agent. So that I think that's what I was trying to get to in a second before. So agent. So okay. MCP servers are basically a facade on your existing infrastructure. When I say facade, it is going to stand in ahead of could be your REST endpoints that your organization already has, right? And your organization can have how many ever endpoints you want, right? And those can be used, those can be exposed to anybody else who is using those MCP servers, right? As tools. Now, you could have your own organization's REST APIs coming through one of the MCP server. You could have a Jira endpoint, Atlassian's endpoints coming through an MCP server, and you could have GitHub endpoints coming through an MCP server, right? A code agent, like how you were talking before sometime, right? A code agent is given access to all these three MCP servers now. A code agent here, right? Agent uses the LLM, right, to look for the right tools it can use. And how do these tools come? Through your MCP servers that you are trying to expose. Is that okay? Add on to it. Yes.
MCP servers are independent of LLMs. It's for you, it's a standardized way for you to expose capabilities which your organization has, which agents can consume, right? Agent can access an LLM as a service. It can access MCP, and it can access both to accomplish a task, right? So it's like it works in coordination. Agent it becomes the brain which is coordinating across one or more MCP servers, one or more LLMs, right? I think that's the picture that I was trying to bring out. Yeah.
Like this. So we were just talking about tools all this time, right? Now, what does this resources mean, right? And there is I had a hard time understanding if RAG was solving that problem before, why do we need resources, right? Both sounded very similar. Resources are basically, it can be either a static resource, like fixed documents, right? Or it could be some templated resource, right? And when I started reading more about it, that's when I even got clarity in this area, right? This is one example of how a resource and tools could work together, right? Think of you are bringing an employee in, right? And you have certain onboarding steps that you have to do for that employee, right? Onboarding steps are basically listed as part of steps in your organization's document, right? And that could be a fixed resource that your LLM first consumes to find out what are the steps that I have to go through to get this employee onboarded. Okay. Now, for the first step, what is the tools I have available? Okay, maybe I need to create an employee ID or something in this table. Maybe I need to initiate a background check. Step 2. Maybe I have to maybe call this API for a background check. Maybe this call a different API for creating an employee record, right? Maybe create an create a laptop request or something for this employee, right? Those are the steps. And for each of those steps, you are giving tools. These don't change. Fixed resource. Once you have all these steps done, or maybe even one of those steps will be an initiation. So as soon as you initiated an onboarding, background check for that employee, right? You want to send an email to them, to that employee, the new joinee, saying that you need to click on this link to get your onboarding process started. That email template itself as a templated resource. It can have placeholders inside it. It can have your organization's branding and everything written inside the email template, right? So pick up that template, replace it with stuff, right? And send out an email, right? And who is doing all this? Your agent through an LLM. Okay. So far with me, everybody? All right. Okay, so this is one way of thinking of how these things can work together, right? Now, how do these things work under the hood? As far as the every major MCP server or any agents that you're seeing today live working are conforming to the November MCP standards that came in. There is also a March standard which is out, which is, for example, the streaming HTTP that you see as one of the protocol that is being listed over here. Not many clients have implemented this so far. It's getting implemented. So if anybody is doing work on these areas, the two protocols that you would use today is standard IO and server-side events, SSE. Okay, SSE is nothing but, so when I say standard IO, one thing to keep in mind is if your MCP is doing work through standard IO, it is through a local process running on that particular machine. Okay, there is no HTTP calls or no web calls that go out through the standard IO protocol. Okay, I'm not going to show any demo of SSE today, but the hello world kind of demo will be standard IO basically. So think of this, right? You can have a Claude like tool over here, right? And I don't know how to zoom into this, but this is the max it allows me to do. So I'm not going to go inside. But if you see here, what I'm showing here is the Claude desktop tool, similar to what GPT gives, right? Claude can also be used online as well. This is the desktop version. Desktop version is where you can have MCP tools linked to this, linked to Claude. How do you do? So this is not a demo as such, but I'm just showing on like what can these tools do through standard IO, right? Now, not this. Sorry. What Claude does is they allow us to write a Claude desktop configuration.json. Okay. Now this JSON again is nothing owned by Claude as such, nothing owned by anybody, right? But this particular file that I'm showing, Claude underscore desktop underscore config.json, comes along with the Claude installation that you do on your laptop. And where does that sit? It sits inside your app data. Yeah, it's not important about how to know about all this stuff, but I'm saying like this is the common pattern everywhere. Even if you open your cursor, even if you open your VS Code, there is an mcp.json that you are going to find, right? That's where you are going to say what are the MCP servers that you have on this machine, right? Or else like when I'm showing this particular thing, Claude desktop.config.json, I'm saying that, hey Claude, I'm giving you all these MCP servers that you can use along with the Claude desktop, right? Now, if you see here, one of these servers, right? So this is why I was saying initially, when I say server, as soon as don't think it of as server, right? So whatever I'm showing here, this is a server. It's a file system server. What does this do? It accesses your local file system, right? Helps your Claude desktop, Windows application basically, to access your file system, right? And here I am saying that this is the command that you will use with these arguments, right? I am saying that these are all the paths that I am giving you access to, right? Go read this. So if you see what I have done is I asked before some time, use your MCP tools to access these local paths, right? And it is reading that path and it is telling me, okay, this is all the files that you have and this is the kind of project it is and all that, right? And how did it do this? By triggering a local process inside on my laptop to read that folder, to come back to me and tell like what's the folder about. So if you see here, this is the way I am telling Claude that there is a server available that you can use, right? Now if I say here, I will go to Claude desktop itself. Okay. Maybe replay this message itself again, right? Yeah. So if you see what it is doing is reconfirming what I did, what I told it to do, right? And here it is asking me a prompt, right? We will see this in the presentation as well in a minute. This is called as human in the loop. So you cannot, so all these AI tools, right? They amplify everything, whatever you give, right? So you always want a human in the loop to be there to see what it is actually doing. Even I'm saying this is, here it is just reading a folder, but when you are actually doing your code generation in VS Code using these tools, right? That's where it gets even important to watch with your developer eyes to see what it is actually doing and make sure that it is conforming to your standards and it's not writing some junk. Personally, I have seen it doing a lot of shady things. Definitely never write both your code and your test using the same. It's a recipe for disaster, right? Either it will write so many tests where like, which is not even related to your context, right? And or it will write some code which no other developer later can maintain a bit, right? So that's the big problem for us, right? As developers, somebody else has to see this, right? And you know what they will talk about you when they read that code, right? So definitely never do both at the same time. Either you use LLMs to write your tests, or else use the LLM to write your code, right? And either way, we are responsible to make sure that it gives us what it needs, right? I'm saying all this for production level applications. If you're just doing a small new from the scratch application, which is going to have like 10, 15 web pages or something, and doing some standard login, logout, regular database stuff and all that, this is not a problem, right? We have seen demos where you can give one project requirement document, you can list down cleanly what you want. A VS Code can develop the whole application for you and make it stand. I'm saying this is for people who can understand code. Bolt and Replit are already doing it for those people who don't even understand code, right? Well, we are deviating a lot, you know. So human in the loop, I'm able to give a response to it saying that, okay, I am letting you read, execute this command and go use this file system server with the list underscore directory as the tool. And this is the request that I am sending to this tool, right? And I'm able to send that and get back a response from it, from the LLM itself. Now, we will come to all this in a minute again. We'll go back to what we were seeing before, right? Yeah. So I was just, whatever I was showing now, this is standard IO, right? To go a little bit more even deep into that, standard IO is nothing but when you do a console.log when you're writing your application, right? So I am a C# developer, so everybody who is listening to this, translate into your own language that you understand, right? So when you do console.log, whatever logs that you see written on the terminal, right? That's standard IO. And your LLM and your MCP servers are communicating through the standard IO. So remember one thing, right? If your host or your MCP server is also going to write to the same standard IO, you are correcting the channel. Yes, that's a little bit deep thought to take in. You are correcting the channel of communication of how your LLM is talking to your MCP servers. So how do people come out of this? Use a different pipe, STDRR or something else, right? STDRR, some different pipe which is not standard IO basically, to make sure that that channel remains open for them to talk to each other, right? And just because of this problem, it becomes so hard to see what kind of communications happen between your LLM and your MCP servers when they are talking to each other using standard IO, right? All you can see is that, okay, you cannot really see, okay, which port is basically open and which process is getting, you can see to a level, but you cannot drill deep into it. And when I am telling standard IO, right, your LLM, which is running on your local, is talking to the MCP server using standard IO. That is the only part which is working on standard IO. Your MCP server can do whatever it wants. It can go talk to an API. It can go, it can query some tables running on your local SQL DB, right? So if I was just doing that before some time. If you see here, here in the Claude desktop, if you see here, I have a SQLite server, SQLite DB, right? And this whole, where is this DB stored? Test.db is the file, okay? And this server is how I was able to talk to using this Claude desktop. Here I am asking, do you have access to my SQLite DB? It's telling, yes, I have access and all that. What tables do you have? It is doing a list tables tools it is executing, right? And it is able to tell me that I have a products table. I'm asking what kind of list me all the rows into the table and all that, right? And it gave me saying that okay, I have all these rows into your table. And mind you that this is a DB which is running on my local machine, right? And I'm able to tell, can you update this record to some other thing, right? And it is updating the record and it is telling me that I have updated it successfully, right? So this is just one way how these how the host here, the Cloud Desktop, is using the SQLite server through standard IO to update the local DB here. Okay, so this is one way, but there is also different. So I'm not going to scroll a little bit down because I have my API keys over here. So I'll just stop here, right? So here I am also able to tell that I am able to give you a GitHub server, and I want you to go. I'm giving you my GitHub token using my environment variables, basically, right? So and I'm asking it to go access this specific Docker container which is already running on my local machine. So I'm saying that what can basically this standard IO do here, right? So we are running very short on time, but I'm happy to answer more questions at a later point through our WhatsApp or anything, right? But standard IO is just the way your LLM is going to talk to your MCP server. Your MCP server can access your local process. Your MCP server can go call an endpoint. Your MCP server can edit some files. It can do whatever it wants. That is different. Nobody is questioning that, right? But what would happen if we want this to be a more stateful communication, right? When you want your MCP server to come talk back to your client, right? And if you want to run this whole, the resource that you're trying to access itself is not sitting in your local, it's sitting somewhere else, some web server. That's where SSE comes in, server-side events, right? This is, again, I don't have a demo for this, but probably in next sessions or something, we'll see if I can get the demo for this as well, right? Very quickly, we have, okay, and streaming HTTP is something which is coming very new. Difference between SSE and streaming HTTP, both use RPC on the backend, remote procedure call. The only difference between these two is SSE is more for stateful communications, right? Where you have heard of sticky sessions when you know that the request is going to come back to the same node, right? When you have multiple nodes running of your application, you know that the response is going to come back to the same node. SSE works fine, but it fails when you have more stateless communications. That's where streaming HTTP is trying to solve that problem. This is again, like I said, March product updates. Still, many are trying to implement this. Okay, human in the loop. We just saw how the human in loop works. But one thing to remember is, even though it is a specification written in place, it's up to the host developers to enforce it. Okay, so when I am showing the prompt which the Cloud Desktop was showing, the developer who did the Cloud Desktop has made sure that they conform to this specification, so that they go ask the user for the permission. Hey, this is the can I run this tool using the server? Can I have your permission on this, right? And that's the human in loop confirmation that we are trying to get, right? And again, so if the developers don't do it, there's nobody who can question them. But I'm just saying, it's like a difference between a put and a post, right? You could do creating of resources using a post. Nobody's going to question you, really, right? It's about how you write those specifications again. All right. And when you okay, so this we already saw. Okay, and one nice features that so if APIs are already very common language that every web application talk to, then why exactly do we need all this MCP and all this, right? So every time an MCP client, when I say client, again, your application, your VS Code or whatever it is, when it is trying to connect to an MCP server, it is going to go connect to the MCP server, ask, hey, what are the tools you have I can use? And it is telling that, okay, I have 2 tools I can use, you can use, right? Now, as an app developer, I don't have to make any changes to my application on how I will use those tools. Think of it, if you have written code for communicating to a REST endpoint or communicating to any SOAP endpoint, right? You need to know the schema, what you're trying to read, right? You need to exactly know which endpoint you're trying to invoke or read, right? Now, which means even though somebody has written that endpoint somewhere, right? We as application developers will have to put some lines of code for invoking that particular endpoint, meaning I have to make some change. That is changing here. The client, when it's connecting to the server, it is saying that, okay, what are tools you have? Okay, I have 2 tools today. Tomorrow when it connects, oh, I have 3 tools you can use today. Great. I don't have to make any single change in my client code, right? And who is going to use these tools? My LLMs. Depending upon the smartness of your LLMs, like you pay more, you get GPT-4. You want to go cheap, go Ollama or whatever it is, right? So depending upon the smartness of the LLMs, they understand how to use these tools. And how do they know how to use these tools? That depends on the description of these tools that we give. In a second, we will see how these descriptions are being given, right? And again, we covered most of this in our talk as we have went, right? And these MCP tools are more specific built for the LLMs and how to access their resources outside. Discovery, we just spoke about it, right? And how these endpoints get discovered outside, right? And client updates, we just spoke about it. They don't have to they don't have to do any client updates. And basic standardization, right? So standardization, very important here, right? So you can use this whole, you can have like 10 MCP servers. Today you can be using Ollama. Tomorrow you can switch to any other model. No MCP servers change. MCP clients, they don't change. None of these changes. You just switch the model. That's it. Right? So, and abstraction, yes. Okay. Now let's quickly, okay, before we get inside on how to run these things and stuff, right? There is this inspector that we can use to debug. We will see this in a minute on how to use this. Authorization. Okay, authorization. So this is still something which is being talked about on how to implement this and all that, right? But the current way of how this is being thought of is that there is something called a well-known endpoint. I don't know, like I didn't know about this before some time, so I assume many don't know as well. So if you see here, accounts.google.com, right? I'm if you see what I'm doing, after that I am doing a dot well-known / OpenID configuration, right? These are well-known endpoints, that specific domain exposes on how the connecting clients to the domain can go look for accesses. So here what you're seeing is that, okay, where is my OAuth endpoint? Where is my authorization endpoint, right? And what is the response type and all that? What are the token endpoints that I should be calling and all that? So this is nothing secret. This is open. Okay, all major websites expose this. Shopify has its own well-known. Everyone does this. Okay, so the way. Okay, give me 5 minutes. Let me wrap this up then, right? So, well-known endpoints is a way it's being and how are they planning to do this? They are planning to expose a location of a protected resource metadata (PRM) document, and PRM document and that is going to come through your well-known endpoint which is being exposed. And that will tell how these clients can discover the servers for the clients who are connecting, right? So there is nothing much over here. So what I will do here is, okay, so I am running one project here, which is, this is nothing but our C#, where is that? Yeah. Oh, this is a gold treasure. This portal, model context IO protocol.io. You get access. You get information about detailed information about how these architectures are and how each SDK is done and all this, right? And what is generally available today. That's what you can see here, and you can still go inside what's in development to find out what is cooking at this point. Okay, now C# SDK, whatever you are seeing here, that is the repo that I have cloned to my local to show this. Okay, so all of this is public, so I'm okay to show this thing now. Okay, so there is if you see samples folder that I am showing here, I have two servers that two things, right? And there is an everything server over here, and there is a chat with tools. And this is a chat with tools is a client that is trying to connect to this everything server, right? If you see this chat with tools, if I go inside program.cs for this, right? All it is doing is that, hey, and I'm giving my OpenAPI key over here, and all I'm saying that, hey, I want to use the standard IO client transport, right? STDIO that I was talking about, right? And I want to connect to server hyphen everything. That's the name of the server that I want to connect to. And how do you connect using your node package, right? Now npx. Now, okay. So now now what we'll do is we will use this client to talk to a server which is going to run here, right? Now I have two PowerShells over here. One is pointing to everything server, and other is pointing to chat with tools. Okay. Now if you see here in everything server, so I'm going to show you the inspector that I was talking about. Yeah. So say MCP inspector that I was talking about, right? Now if you see, this is running on this port, and when I am trying to connect, there is things happening in the back end, if you see, and like I was telling you, if they are not using console.log for this, they are using a steady error for this. That's how they are able to, that's why you're seeing this in like error output and everything, right? Now, if you see the status is connected, as soon as the server is, this is now here, this is the client that I am using to connect to the everything server that I am running in my local, right? Now, there is a tools, prompts, and resources. When I do tools, when I'm doing list of tools, what time is the prayer? Right. Okay. Okay. So, okay. All right. So basically, tools. Again, it would be super good if people can go clone this repo, run it on your local, and only then you will know how to do this. And most of it, like the code that I just ran now, is basically it's basically telling that. See here. All I did was just ran this inspector command here, right? Inspector command, and I'm saying .NET.run is the command that you need to run, and it invokes the server. And as soon as I did that, the server is up here, and I'm able to show all the tools the server is exposing, right? And I'm able to show the prompts that the server is exposing, and able to show that there is no resources into this. This is one client, right? I can also do the same thing using a different client. If I go here, there is a different client over here. It is connecting to the server. So if you see, it's the same server. Two different clients are connecting to it. One is the inspector that you just saw, and the other is this piece of program.cs code that I'm showing here, right? Now here also it is able to tell me that these are the tools that I have that you can use. And this is run by this thing. Here I am using an LLM as well along with it, right? Here it's not so easy for me to type and hold the mic as well, but I'm saying all I need to do is just go type out the questions that you would ask an LLM, and you can ask the LLM to use any of these tools to show the show the ability of how these LLMs can use these tools. Okay. Probably we can do this when Brother Majid shows this week. Maybe we can show all these demos. Okay. Yeah, because I have more demos that I got prepared, but I know. So yeah, we'll do this a little bit later though. So yeah, I'll conclude for now. So there is another session being planned for next week or in the middle of week. I don't know. Yeah, we are still talking about it though. But if that session happens, probably I'll show whatever I was not able to show today in that session. Yeah, I'll also try to do the SSE as well. Thank you.
Okay, I guess Leslie.
Just like what you presented now, the MCP standard, right, the protocol, Google has released last month, I believe, A2A protocol, right? And that's going to become the next standard. No? That's for the agent to agent. Absolutely, yeah. They're right. But in the correct, they'll coexist for some time, right? Yeah. Eventually, they might come. Right. Yeah. So A2A to come.
Assalamu alaikum. Great. So what I have is just a collection of interesting topics that I came across. And before I begin, just by show of hands, who pays for the $200 ChatGPT model? By show of hands. No, none. Okay, great. Who uses the $20 model? Okay, good number of hands. Good number of hands. So, I wanted to start with that because you'll see the reason why in a little bit later into the presentation. So, actually, let me as I start. So, the full purpose of this presentation again is documenting the intelligence explosion, sharing important concepts, research, advancements of standalone models and processes, as well as just some personal developments. So I did leave a little message on the bottom, as a warning. We are about to go into the weeds of things. We're gonna get dirty. We're gonna get our hands into the math. So if I get a little too far fetched, please just let me know. So before I start, oh yeah, again, this is just the agenda. Don't try to make this really quick. And a main topic for today is just speaking on AGI and distribution shifts. So before I start, my name is Esley. Esley is actually a Hebrew name. It. Oh, it's not sharing on there. Okay. Oh no, I didn't. Okay. Yeah. Then yeah, I could try sharing that real quick. So. Okay. So let me just. Sorry for the.
Or is it faster to send the presentation to someone? Yeah, he can share already. You share. I think then exporting the
But I'm thinking like, actually we are missing two speakers. Two speakers will be needed much. Because I took a lot of time for it.
My presentation will be under 10.
Okay.
It will be under 10.
you can take 30.
that works.
So that previous procedure was showing now on I'm also going to check the
So again, yeah, sorry for the, so yeah, we're at the agenda. So this is just the topics for today. As I mentioned, I'm going to briefly speak on AGI, scaling laws, distribution shifts, and just a little framework that I put together myself. All right, so before we begin, I just wanted to give a quick background on myself. My name is Esli, and Esli is a Hebrew name. It actually means "at my side is God." I am a self-taught machine learning engineer. I really enjoy this type of work. You know, I consider myself a late bloomer at being an engineer. These are just certificates that I got just last year. My background is in financial engineering, so I ended up taking advanced calculus, linear algebra. So that opened up my world and started understanding the abstract behind and the math behind language models. So my background right now is I'm a quant researcher. I focus on vulnerability forecasting and exploitation. I use machine learning and AI to accelerate the production rate of processes while increasing efficiencies in breach and attack simulations, autonomous penetration testing, and reverse engineering. So many of the topics today would have, I will speak in the tone or in context of red team or white hat hacking. This is just a photo of the MERT attack matrix, and I plan to utilize this, and you'll understand how I include this in the mix. So what started my journey in AI, I went to a financial engineering event. It was the Future of Finance, Future of Machine Learning event at Cornell University. It was the tech campus in Manhattan, and I ended up picking up this book. This book is valued at $70 on Amazon. The author, Marcos Lopez de Prado, he is actually the quant of the year. He was voted quant of the year in 2019, so I was in good standings there. So this book opened my eyes and actually got me to enjoy, or learn machine learning. These are two books that actually inspired me and driven me to become more adept in math. I am a late bloomer as an engineer. I started off as a finance major in college, and I learned options, derivatives, but I never went too deep into the math of it. So it's until now, not too long ago, I just got into it. So why I asked, does anyone use the ChatGPT Pro models, is because on September 12th, the reasoning model ChatGPT 01 was released, and that was my reaction. I mean, when that model came out, I thought that this was it. We finally have an intelligence that we can have in our back pockets. As smart as a PhD. And October 30th, I went to this event. You guys are probably familiar with Crew AI, one of the agentic frameworks. They held a hack night with Cerebras, and Cerebras is that's one of the photos. Cerebras is actually a startup computing company that is specializing in fast inference, and they're competing with NVIDIA, not the same size as NVIDIA, but their niche is in fast inference, not training the models, but making them increasing the speed of the output of the models. So this was a really great event, and I got to meet many different programmers, different hackers, and we was able to share ideas. They spoke on the new frameworks. Crew AI was there, one of the representatives, and so was Cerebras. They was actually giving out free cloud credits, so I still need to use those. Okay, great. So AGI and the moving goalposts, all right? So just as a basic definition, AGI is a highly autonomous system that outperforms humans at most economically valuable work. And that's actually from OpenAI's website. So OpenAI in September 12th, they released the 01 model, and there was also stages of artificial intelligence. And I particularly believe that we are past level 3. I believe we're at level 4, where we have innovators or AI that can aid in inventions. And I don't have many posts showing the aiding in invention in innovations, but if you go on Google and just type in like research agents, you see many different breakthroughs in science, math. The speed of research is breathtaking. So as a warning, I believe that AGI is here. And the reason why we don't know that is because we're not spending $200 a month for it. So that's just what I believe. And I'm open for arguments. So my presentation, where the argument really begins, is the scaling laws. So, and during '01, the release of '01, the terminology of test time compute came out. And what test time compute basically means is you're adding compute to the model when it's during the inference time. So it's basically thinking. That's how the reasoning model was given birth. And the co-founder of AI Labs, Safe Superintelligence, said scaling the right things matter now than ever. Because previously, before '01, we had really large language models. We had language models of 400 billion parameters. What they're arguing now is you can have a smaller model, but just increase the compute during inference. And this was on the right, we just have someone from Microsoft saying the same exact thing, the CEO of Microsoft saying the same exact thing. And underneath is OpenAI's influencer, who is essentially agreeing with him on this point. And what I have here is the two charts. One to the left is the photo release showing the log scale of how test time compute improves over time when you increase the compute. And to the photo to the right, this was before '01. When I point my finger to '02, if I point the mouse to '02, that's where we're technically at right now, because ChatGPT skipped '02 and went to '03 due to the copyright license with the stadium in the UK. So we're actually here at '02, although ChatGPT's newest model is '03. So they're pointing out that they're estimating that where the scale that we're going, the previous scaling law, where we just have large parameters, has plateaued. And in the summertime, we finally hit a new scaling law where rather than building out really large models, we just train small models and then add as much compute during inference time, allowing it to think and reason, and we're just gonna hit a whole new scaling law. So right now, we're only at '02, although the name is '03. So can you imagine what happens when we're at '04? So the two terminologies I have up there is test time compute, which describes giving inference or adding compute during inference time, basically allowing it to think. The topic of research that I enjoy studying is test time training, which is, okay, I will skip this one. Matter of fact, this is actually really good to show because back in April, this was the release of '03, and ChatGPT put up a whole bunch of different papers saying, this is where we're at. The advancements, this is the smartest model out there. This is the most capable model out there. And they just keep pumping out new things. This comment I saw on Twitter, the new ChatGPT model has over 600 tools included in the model. So, I mean, I don't know, the tools, to me, I see that as giving a model fingers. I don't have ChatGPT Pro. I'm not spending the $200 a month, but this is just insane to me. This is actually having a small assistant being able to do really small tasks for you. But I'm gonna keep going ahead. Manus is another company. They're from China. Once they released a similar model to what ChatGPT produced, and it's actually the same price, $200. And kind of funny how they say they're the general AI agent. So I don't know if that's AGI or not. They're not saying it's AGI, but I think that's plain and simple to me that this is AGI. And here's just the system architect and how they build it. There are a few open source initiatives, not perfect. I believe that someone can build it. And this is just like a simple architecture, but I could probably skip to where some of the use cases. This is just a benchmark showing the general AI assistance benchmark and how it outperforms ChatGPT's deep research. And this is just the use case gallery. It's able to do front to end small projects. So something like analyzing stocks, analysis of different insurance policies, trips to Japan. But mind you, this you have to spend $200 plus a month for. Not everyone has that, but if you do, you will get to see the benefits of having this. Now, this is actually one of my favorite MCP clients that was just released, and I'm glad that we was able to go over the understanding of MCP. This is actually a model or an MCP client that directly talks to your terminal. So if anyone writes a lot of script in Bash, this right here talks directly to the terminal. And they have an MCP for this. And this video just came out 11 days ago, and the caption is now the best MCP client in 2025. And this is just a few add-ons to this, and I want to emphasize again the intelligent terminal. So if anyone writes a lot of Bash scripts, they're systems engineer, you can talk directly to your terminal, and it can reason and talk back with you. And this is just a chart showing the scale logs. This research paper was from an ex-OpenAI fellow. The name of the research paper is called Situational Awareness. It came out last year and actually showed that once we get to the point of having automated AI researchers, we're going to just explode. We're going to explode in cognitive labor. We're going to explode in science, technology, robotics, military edge, and GDP. And the research paper to the right is actually the same situational awareness. And it quotes on there that AI progress won't stop at human level. Oops. Hundreds of millions of AGIs would automate AI research, compressing a decade of algorithmic progress into 1 year. And I just kind of have like a funny photo to the right, having an army of PhDs in the data center. This is the goal. And just having a comparison between AGI and superintelligence. Superintelligence is the sci-fi. That's in the movies. And there are many bottlenecks that are stopping us from getting to superintelligence. But general intelligence, AGI, I believe is here today. They compare the two. The impact of AGI is not as high as superintelligence. And clearly, if superintelligence is here, we will all know. We will be panicking. So again, my goal is to have an army of PhDs in a data center that can do work for me. All right, now we're gonna get to the fun part. All right, distribution shifts and real world implications. So we all know what the transformer is and how, the transformer is what is behind ChatGPT. And the paper "Attention is All You Need" is what brought this to life. And simply, if I can wave my mouse, the input embedding, the two things I want to just point out to you guys, I don't want to lose you, is the input embeddings, output embeddings, and the multi-head attentions. The input encoding or embeddings is where you give the tokens. Is you either give text, images, or videos. And the multi-head attention is the matrix multiplication. That's the science that gives you the probabilistic answer. Now, with the transformer, the multi-head attention is fixed. The parameters are fixed. In the training phase, you bake the parameters in, and once it's baked in, then you release it to the real world. The issue is most of the time, when in real world use cases, there are distribution shifts. So the model is incapable of solving the problem because it hasn't seen the problem before. Now that's where test time training comes in. You probably asking me, how are we capable of unfreezing the parameter heads and giving it the ability to adapt and to think? And The answer is we use another AI model inside of the AI model. This is like really crazy stuff, but just hang out with me. You will understand the reason why. Test time training is just a supervised is a method used for self-supervision training for generalization under distribution shifts. There are two examples: test time training and test time adaptation. The adaptation part is actually combining test time compute, which is giving the model to reason and to think, and test time training is unlocking the parameters, allowing it to shift its focus and shift its focus towards other parameters to solve that initial problem. So basically, this is the paper, The Surprising Effectiveness of Test Time Training for Abstract Reasoning. It showed that when you add test time training to a model, it significantly increases the chances of solving abstract problems, so really difficult problems. It's essentially like cheating on the test, using open book on a test to get the answer. That's why I have the photo to the right. This is just one paper that shows another method of test time training. Is actually using a recurring neural network, so it's not a transformer. The thing with this is in test time training, the self-attention head that I pointed out to, it grows with context with the hidden state. It grows with context, meaning that the fixed transformer model, the more context you give it, it kind of breaks down. So in this case, test time training, you can give it unlimited context and it will be able to reason. So this is just showing how we add test time training into the transformer. This is my favorite test time training model, and is actually up on GitHub. It's open source. So this is just my system of design. So what I mean by system of design, I'm trying to replicate ChatGPT's Pro model, the $200 model. And I would like to add some extra tools to it to make it more efficient. Sam Altman said that building AGI is a scientific problem. Building superintelligence is an engineering problem. So this is where the engineering background comes into play. AGI is no longer science fiction. Superintelligence emerges not from a singular model, but from the specialized coordination of multiple pre-trained language models working in coordinated harmony. This collective intelligence, driven by collaboration and specialization, surpasses the capabilities of any standalone model, and I'll be able to prove that shortly. So simply, it will be individual frontier models and open source models continue to improve over time. Agentic workflows, which was spoken on earlier, are becoming more and more autonomous, proven by the ChatGPT Pro model and Manus. And access to tools is giving it fingers. We now have language models that are capable of accessing the real world, touching the real world. Small language models and vision models, I wanted to add that later, vision models so it can see itself, see the world, and interact with the world. Then we have smarter AI using test time compute instead of just using bigger models. So the ex-CEO of Google AI, Eric Schmidt, last year he said that we will have superintelligence, or we will have autonomous agents once we have large context windows, agentic workflow action, and text to action. He added that recursive self-improvement, meaning that if a model is capable of improving itself or figuring out where it's wrong at and improving itself, then we will have the AI systems would essentially just be far than what we can possibly imagine. And just to read the exact quote, he's highlighting his belief that AI systems are on the verge of becoming capable of learning and improving their own capabilities without constant human intervention. That's something. And this is the ex-CEO of Google, Eric Schmidt. He said this last year, and it's on Google. It was taken down, matter of fact, because he's a big-time VC, and people didn't really like what he had to say. And mind you, again, he ruffled a lot of feathers with that comment. Let me just move. He warns that if computers can begin to become self-recursive, we're going to be in just a different world. We will be in a different world. He says within 6 years, minds will be smarter than the sum of humans, scaled, recursive free. So that's something. So this is my framework. I start with adding as much context and memory as you possibly can, given the scaling laws, training methods, and the frameworks as I mentioned, the test time compute, test time training. The test time compute, these are just topics that the scientists are using to help or to get the model to think. One thing I wanted to point out was the reinforcement learning inspired training. Is anyone familiar with reinforcement learning? Okay, that's good. Reinforcement learning is iterative learning, allowing the model to make mistakes and learn from those mistakes. Normally, it can be self-supervised. You can let the model just do its own thing and it will learn. And other times you have human in the loop giving it the correct answer and it will work on that. And it's the same concept as well. You freeze the weights once you get the desired outcome and then you test it to the real world. You don't see that with just not only just large language models, but you see reinforcement learning in robotics. So this is just a few methodologies behind test time compute, and we see different models such as DeepSeek R1. We notice there's many reasoning models that are out and available today, and they all are different in how they get to their capabilities. I'm just showcasing a few examples on how they got there. So if any of the names look familiar, you know, you can you know where I'm coming from, such as Chain of Thought, Monte Carlo Tree Search, Agent as a Judge, React. These are just all different ways to make the model reason. So these are just a few research papers again on to add to that. This is just my full system of design added. So basically, this is my twist to Eric Schmidt's 3-point system, having large context windows, an agent system, text to action, such as the AGUI, which I'll dive into a little bit after, and vision models. So main thing is I want to be able to have a model that can look at itself and improve itself. So rather than a human saying, hey, you made a mistake here, we can have another model or an agent work on the output of another model and be able to correct it, giving somewhat of a recursive training. These are just a few AI players that offer products in memory, agent orchestration, and inference. Inference is really important to me, and I showed that with Cerebras, the hacking event I went to in October. The speed of the output. You have some models large models that it will take some time for it to give you an answer. Inference can allow almost 1,000 tokens per second in output. And that can be very helpful in agent orchestration, having agents talk to each other. Oh yeah. Shall do. So that is no problem. So overall, the main purpose of this presentation was just to describe that I believe that AGI is here. And I'm just gonna scroll all the way to the bottom, all right? And this comment here just says, sorry. This comment says, please start building now. Do anything with AI. Your best bet is to be as close to AI as possible and be part of the revolution instead of getting crushed by it. And I just wanted to point out YC and what they're looking for in startup companies. So if anyone is interested in building vibe coding, which is called, you know, a lot of people are looking for new ideas, and agents is giving people the lower barrier of entry to be able to build. And I just wanted to put this up. Senators are breaking big tech's grip on Pentagon deals. So more opportunities are being or will be open for smaller players. So this is my link tree, and that's the QR code, and it will just link you to my LinkedIn and other presentations. And yeah, thank you again.
Thank you so much. Very interesting, actually.
Assalamu alaikum. Almost sleepy, right? Huh? It's shared. It's shared. All right. Let's begin with how many of you trust with whatever is being presented in all the things, WhatsApp, messages, the news that comes up, how many of you really trust it? You trust it? The things that come up on your social media and things like that? Wow, that's good. We've lost the trust, right? We don't know what's correct, what's right, what's wrong. So, and that's just increased by day and day, and with the Gen AI, things that can happen with you provide one particular image or video, and then that completely you can change it, things like that. Video, everything, right? So we've been hearing the goods about the AI. I'm sure and I think Dewan mentioned about some of the things that the human in the loop that has to be there. Those are all the things that what I'm more interested in, and that's something that we look into a little bit more closely on when it comes to the AI ethics of it. I'm sure these are just the numbers, the different issues that are coming up. I think everybody can relate to it. I don't have to go into the details of it, and there are various types of things that are happening, right? Right from bias issues, the governance going wrong, things like that, and that's why we need to come up with the explainable AI. That's what the world is looking for. Again, not going into the depth of the what explainable AI is basically making it more explainable to the humans, who are going to be using it, and how this is going to be implemented, how whatever the decision is being taken, that it kind of shows what the decision is, and that is something that is what the world is now looking towards, in the way that to make it more safe, more trustworthy, building the systems which can be trusted. That's the thing, and that's why the ethics come into play. Ethics are it's defining what the moral ethics are, what we believe in as humans, what we believe in, and that is what something that how do we implement what we believe in into the system, because the machines are learning. The machines are going to be acting as humans, or rather taking over and taking decisions on whatever is being done, right? So that's why we have to define what the fairness is, what transparencies are, and different aspects of what our day-to-day life is. We have a trustworthy system within ourselves. We trust people. We trust some of the transactions. We are accountable for many things. So similarly, these things have to be built into the system. That is what how you define this is called the ethics, the AI ethics, and how you implement that is called the responsible AI. When you implement this defined ethics, it becomes a responsible AI, right? And why do we have to do this? Gonna skip that. Okay, yeah. I just put a thing that it's also a call to action for Muslims. It is something that we have to be standing there for good. We have to be there as a representative of good. Because that bad can come out of it. If we developers or we who are in the system, we have to make sure it is ethically correct. Implement the systems in an ethical way. So hence it is very, very important. As a Muslim, I do believe in it, and I really believe in it that this is something that I have to stand by, and be the cause for it. And other than that, of course, the regulations are coming in. Though they are catching up a little bit late, but they will come in. The regulatories are going to be coming in, right? And what is regulatory? Regulatory are nothing but these acts and the impose. There are different types of regulations. One, it could be a soft regulation. The other one is it could be a hard regulation. Hard regulation is you'll be penalized if you're not complying to a particular regulation. Soft regulation is they'll let you go, but this is what something is being prescribed. This is something that is something prescribed, or this is something preferred. but the government is not coming behind you at this point. That is something called a soft regulation. And the regulatory regulation is kind of depends upon your compliance. What is regulatory? It says that, okay, you have to comply to something. You have to comply to something. That something could be an act. Something could be a bill that is being passed in a session. Something could be a framework, guideline, things like that, right? And those compliances are based upon your standards. That is what defined standards. Like, you just take this bottle here, right? This bottle is having a standard to it. It is complying to a particular standard, and any manufacturer has to comply to this particular standard. If it is not being complying to the standard, then they will be penalized for that. So who defines? Yes. Yes. It is coming. Yes, that I'll be talking about where we stand with respect to regulatory, like which country is where a little bit, and so that's coming up. They are, as I said, they are typically the regulations come, and it's also from a government perspective. What happens is they want to, even though they know this is important, they let it loose, because if you catch it up right at the time when you are blooming, then the innovation doesn't come up. So some of the countries, they just want to let it loose, so that let the innovations have come up, let there be some market penetration and things like that. Then they will bring in the rules and regulations later on onto it. So what's happening right now globally, right? If you look at the first one to come out was the EU AI Act. The EU AI Act is something that has been already in place now, and especially Europe is leading in all these ethical aspects of it, and they are pretty much strict there. And they have within the AI Act, again, they have multiple things that are going on over there. I know, like few years back, the GDPR was not there. But the personal data rule was not there, but now everybody is implementing it, right? Similarly, there'll be a time where the AI Act will be imposed upon everybody, whoever is doing any kind of service, any kind of product that is in AI, they have to adhere to it. It again depends upon what level of risk you're playing. It could be a level 1 or it could be a level 5. Because if your application is something to do with healthcare, for example, then you're risking lives, and something to do with which is affecting more people, then it becomes higher level. So things like that, right? And the US regulations, if you look at it, there's no federal law yet. However, there have been few laws that especially some executive laws that are there, and there are different states which are coming up with different laws. Every state has their own laws that are now being imposed upon. UK again, UK though, because they are not part of the EU, but they still have their own laws going on there. China has come up with some generative AI laws and rules there, and then similarly India has the data protection law, and then there are other AI laws that are there. Similarly, if you look at it, in fact, there are more than 53 countries right now who are kind of coming there with some kind of framework guideline onto the AI things. This is also opening up many things. This opens up the regulatory and all the things that are opening up opportunities within the organization itself. Now they have to, like similarly, like in earlier days, like from a risk management, change management. When you talk about so that was a new set of people that were introduced. So every organization now will have somebody who's going to be looking into the ethical aspects of the AI that are getting implemented from their system, from their organization, because once they lose the trust, that's it, right? To build back their trust, it takes a lot of time, effort, energy, money, everything there. So hence there are new opportunities that are coming up. That's what when I introduced myself, I said I'm a AI ethicist. That is another thing that a lot of organizations are there. There are new contractors who are coming up as a AI ethist, who's looking into this. Soon, I mean, there are already assessments that are happening on these systems, which are done by the assessors who are well versed in this particular area. So there are many different opportunities that lay ahead of us. And as I said, there is a close connection of the regulatory to the standards. What are those standards which are driving this at this point? Some of the standards, if you look at it, ISO, IEC, there are certain SDOs, there's standard development organizations who have their own standards there. For example, ISO, IEC, the AI management system is there. And I'm not going to read through each one of them. We are all already running late. But just to give a point that, there are all these different standards that are out there already, which the regulatory is going to be using it, for defining what the AI ethics should be and how the regulation should be. This is where I come from, my organization. I've been involved with these standards and some aspects of these standards here. And similarly, the NIST NIST has their own framework. The OECD has their principles. Other countries, Singapore, Canada, etc., they have their own frameworks as well. Right. Some of the trainings, they're there. And see, one is that, as I said, we need assessors. We need neutral assessors who can go out there assessing all these different organizations, similar to the ISO 9000, right? People, they go and certify. They go and certify this organization, saying that okay, let me certify whether you're adhering to this 9001 or 9000 and things like that. Similarly, we are going to be having the whole thing of getting these systems kind of certified, saying that this particular system and this particular product is adhering to the ethical aspects or not. Right. So. Yeah, so that's true. But see, the thing, if you look at it, even the way today's sessions have been scheduled, right? There's something at the last. We typically look at the non-functional requirements at the last. The functional requirements come into the fourth thing. First and foremost, okay, how does it work? How do I make this protocol? How do I make it work? But things are changing now. Now we are talking about security by default, right? It was not like the later thought right now. So similarly, ethics by default is something that we are looking into. Like, how do I design the system in thinking of the ethics in place? That is what this particular training and there's a certification to it again, which drives through the whole software development life cycle and defining how do you actually define, even when you're a business analyst, how do you define the ethical rules, so that when you're collecting the requirements, you're collecting the requirements separately, one as a functional requirement, the other one as a ethical requirement, that we call it as ethical value requirements, EVRs, and then assessing that, passing it through the design. Sometimes the ethical value, there may be a clash between the EVR and the technical requirement. How do you overcome that? Things like that. That is something that this is based upon the 7000, the standard 7000 that I mentioned about. And similarly, we procure systems, right? Not everything is something that we develop. We procure systems. If you're procuring an AI system, what are the things that, from an ethical perspective that needs to be done? This is again 7019 or 3119 that is there, that we have. So these are all some of the trainings and certifications that are there. Even now, if you look at it, there are many now academy, or many institutions have come up with ethical trainings. They have their whole certification on their ethical training and things like that. So yeah, that's what I just wanted to kind of bring it to bring attention towards, because this is something we should stand by, and before we are caught, especially if we are getting into new development, newer areas, getting into the, but we don't want to get, because one of the stakeholder is something which we don't want is the regulatory to come in and play on us. The regulatory, once they come in, all our effort is gone. Once they come in and put a hold on to it, that's gone. The technologists, when we come up with, we want everything, we kind of live in a ubiquitous world, right? But when the regulatory come in, it can be stalled, and running behind them is a pain. So hence, think about it when we are looking at it. I would like to also have Sohail Bhai.
At least for me, I'm not a AI. I'm just starting to get AI. And basically, what we are doing is we've started a startup. It's going to be a exclusive e-learning portal focused on AI topics. So starting right from basics, starting from this is